Today, we're going to learn how to measure consumer surplus and producer surplus, or, as one of my professors used to call it, confuser surplus. Let's hope that this discussion doesn't add to your confusion, but rather clears it up. By the end of this lesson, I hope that you are able to do 4 things. First, you should be able to explain what consumer surplus is in simple terms. Second, if you have a graph or equation for a demand curve, you should be able to calculate consumer surplus using the information in the graph or equation. Third, you should be able to calculate 2 alternative measures of consumer surplus, called the compensating variation and the equivalent variation. Finally, you should be able to calculate a producer surplus for a market transaction. Basically, consumer surplus is a way to assign a dollar value to how much a consumer benefits from a market transaction. Having such a dollar value can be useful for policy making, particularly if the government is making policies that affect the market in question. The key to understanding consumer surplus is understanding what a reservation price is. A reservation price is the most that a consumer is willing to pay for a particular good or service. We can represent a consumer's reservation prices for different quantities of a product using the inverse demand curve, which is just like a demand curve except that we are describing price as a function of quantity rather than quantity as a function of price. With an inverse demand curve, price is on the vertical axis and quantity is on the horizontal axis. If the price of a good is higher than a consumer's reservation price, they won't buy the product. If the price is less than the reservation price, the consumer will buy the product and will feel happy because they didn't have to spend as much as they were willing to. So, one way to think about consumer surplus is that it's a way to assign a dollar value to that happy feeling we get when we feel like we got a good deal on something. Another way to think about it is that since I have to spend less than I was willing to on one product, then I have money left over to buy other things or to save, and that makes me better off as well. Either way, for each unit of a good that I buy, my consumer surplus is just the difference between what I'm willing to pay and what I have to pay, which is the vertical distance between the inverse demand curve and the price for that unit. Of course, we can add up these vertical distances for each unit of the good that I purchase. The result is that we can calculate consumer surplus by calculating the area of the triangle below the inverse demand curve and above the price. If the price rises, then of course as a consumer I would be worse off and my consumer surplus would fall. The decrease in my consumer surplus is a measure of how much worse off I am as a result of the price change. We can calculate these changes for individual consumers or for entire markets. This is the easiest way to calculate consumer surplus. In addition to being easy to calculate, it also permits a rather intuitive understanding of exactly what consumer surplus is. However, this method only generates reliable results when there are no or very small income effects from a price change. If the income effects are large, this method of calculating consumer surplus can generate very inaccurate results. The 2 ways to measure consumer surplus are compensating variation and equivalent variation. These are 2 ways to measure the same thing, which is how much better or worse off a consumer or group of consumers is as a result of some change in market conditions. When to use which tool is a topic that is somewhat beyond the scope of this class. For the discussion to follow, we will focus on a price increase, which we know will make a consumer worse off. The compensating variation is simply the amount of money we'd have to give that consumer to compensate him or her for the price increase. To figure out how much money that is, start the consumer off at their optimal consumption bundle before the price increase. Let's suppose that the price of good 1 increases. What will happen to the budget line? Hopefully, you remember from last semester that if the price of good 1 increases, the budget line will pivot inward. This puts the consumer on a lower indifference curve than before, which means that she is worse off. If we want to keep this consumer as well off as he was before the price increase, we need to give him or her enough money to put them back on their original indifference curve. To figure out how much money this is, first shift the new budget line up until it is tangent to the original indifference curve. This is the green budget line in the picture. Note that it is tangent to the indifference curve at a different point than before the price change because it has a different slope than the original budget line. To calculate the compensating variation, simply calculate the vertical distance between the red budget line and the green budget line. This is the consumer's compensating variation. Note that because we are paying the consumer compensation for the price change, we sometimes call this number the consumer's willingness to accept the price change. The bigger the number, the more worse off the consumer is as a result of the price change. The other way to measure consumer surplus is using equivalent variation. With compensating variation, we were paying the consumer after the price increase to bring them back to their original utility level. With equivalent variation, we're doing the opposite. We're asking how much money would we have to take away from this consumer now in order to make him or her as worse off as they will be after the price change. So, we're not being very nice to this consumer. To calculate the equivalent variation, start off by adjusting the budget line for the price increase as you did before. Now, instead of shifting the new budget line up to meet the old indifference curve, shift the old budget line down until it is tangent to the new indifference curve. The green budget line is the shifted budget line in this diagram. Note that it has the same slope as the original budget line. The vertical distance between the green and black budget lines is the equivalent variation. Note that since we are taking money away in this case, the equivalent variation is negative. A negative equivalent variation tells you that the price change would make the consumer worse off. One way to think about the equivalent variation is that it measures the amount the consumer would be willing to pay to avoid the price change. If this sounds a little bit like extortion, you're right. A nicer way to think about equivalent variation is that it tells you how to translate a price change into an income loss or gain. For example, if the price of gas increases, it's like an income loss because you have less money to spend on other things. Similarly, when the price of gas falls, as it has recently, it feels like you got a raise. Hopefully, this slideshow will help you to understand what we are measuring when we calculate a compensating or equivalent variation and how to represent these concepts graphically. Next time in class, you will have some practice problems calculating these figures with actual utility functions and price changes. Note that the first step in this process will be a utility maximization problem. So if you're feeling a bit rusty with these skills, you may want to review the materials on utility maximization. Just as consumer surplus is a way to measure how much a consumer benefits from a market transaction, producer surplus measures how a firm or group of firms benefit from a transaction. To calculate producer surplus, we use the inverse supply curve. You may recall that the inverse supply curve measures what the price would have to be in order for the producer to be willing to sell a given quantity of goods. A producer surplus is simply the difference between the minimum price that a producer is willing to accept for their product and what they actually have to accept. For a given quantity, a producer surplus is the vertical distance between the market price and the inverse supply curve. To calculate the producer surplus for the total amount that a producer sells, simply add up these vertical distances. The sum of these distances will be the area of the triangle that is below the price line and above the inverse supply curve. This concludes this presentation on consumers and producers surplus. You will have a chance to use these tools to analyze the effects of changes in market conditions on producers and consumers next time in class.